Okay, so I'm going to talk about the advanced features in JaamSim in this presentation, and some of these things are well documented in the user manual. Others less so because the user manual needs a not good update, which is in the works. So I'll be talking about prototypes and clones, submodels, functional programming, and the watch list input. Those are just some of the things that uh, um, model builders anyone building complex models needs to know about. So first of all, let's talk about prototypes and clones. So JaamSim is object oriented using a different kind of system than you typically see in programming languages. So for example, Java is object oriented with the normal classes and instances of classes. Um, but there's another type to do object orientation, and that's with prototypes and clones. In this case, the prototype is you build a prototype, and then to make instances, you're basically copying the prototype. Um, Whereas in a class and instance system, you create a class and then you create instances of the class. So they're in some ways similar, but it seems very natural in JaamSim to do it this way. And the simplest way to see this is the entity generator. Uh, the entity generator creates copies of its prototype input. In the little example I've shown here, there's the entity generator, and it's creating copies of part. But in fact, it's not creating copies anymore. It's creating clones, and a clone is like a copy, except that its inputs are linked to the inputs of its parent of its prototype. So, for example, in this little graphic, you see part one and part two, the clones, and if you look at their attribute definition list, you see they have this they've defined a attribute num, and that attribute definition is inherited from the parent one, and is shown in blue in the input editor to remind you that it's an inherited property. So this is all well, but the well and good, but what does it do for you? Um, it One of the big benefits of this is because the generated clones have no inputs of their own, they're all inherited. It makes it possible to pool and reuse the clones. Uh, so when a clone is killed by an entity sink, that entity doesn't disappear completely. It's just removed from the model temporarily and pooled with its prototype, so that when another clone is needed, it's there to be reused. And reusing a clone is way less time consuming than making one from scratch. So this is one of the things that makes JaamSim so fast. It can create entities with the entity generator incredibly quickly. So that's a one, small but important benefit of using clones. But the real advantage of clones shows up when you start using submodels. Um, when you make when you drag and drop a submodel from so suppose you make a submodel. In this case, I make a factory model with just a server and a queue, so it's trivial. Um, and that submodel appears in the pre-built submodels library in the model builder. You drag and drop that, you're creating a clone of that factory object, not a copy, but a clone. Uh, and the components of the clone are clones of the components of the prototype factory. So in this case, you see the server object highlighted in factory one. That's actually a clone of the server object in the prototype factory, and all the inputs for that server object are inherited from its parent. So you can see on the input editor, the one on the left are the inputs for the prototype factory's server object, and you see, for example, its wait queue is factory.q, and on the right hand side we see the inputs to the factory1.server, and its wait queue is factory1.q. So it's referring to its own queue, and you can see those relationships by the blue arrows in the graphic above. So what this means is that when if you make add inputs to the prototype objects, you make changes to prototype. All those changes are implemented automatically into the clones. So let me just yeah. So I'm getting ahead of myself. You can also overwrite the inputs to the clones by just entering a value in the input editor. And those inputs are shown in black instead of blue to remind you that they're overwritten values. And if you want to go back to the inherited value, just delete the value in the input editor, and the blue value, inherited value, will reappear automatically. So this whole system ensures that the clones are automatically consistent with the prototype. So if you drag and drop a new entity into the prototype factory submodel, it'll automatically appear in the clone. If you move up the objects around in the prototype, they'll be moved around immediately in the clone. The advantage of this is, apart from it looking cool when you do this, this saves a lot of grief. If you're building a complicated model and you've got lots of clones of an object in it, and the object is fairly complicated, the first model I built with SubModels was a model of a bus route. So I had prototypes for the bus stop, and the bus stop logic got fairly complicated, but it was duplicated. I had clones of the bus stop at 16 different locations along the route. So every time I needed to make a change to the way the bus stop logic worked, if I had to do that by hand with copies, I'd have to make those changes to every single bus stop, all whatever it was, 16 of them. And the chances of me doing this without error is fairly low. And after I've made 5 or 6 different changes over time to the original bus stop, the chances of all those clones being consistent with the prototype would be 0. I mean, it's just too easy to make mistakes, and I'd have to be auditing the input file and just be tearing my hair out. So the use of prototypes and clones, because it does it automatically, it saves you a ton of effort, and it prevents errors that would be very hard to find. And a further advantage of this is that when you save a model, the components of the clones of the clone submodels are not saved in the input file, because they're automatically consistent with their prototype. So they're not copied into the input file, and JaamSim recreates those cloned components automatically when the model is loaded. So this makes the input file smaller. And if you have a complicated system, you'll probably be wanting to audit your input file to make sure it's doing what you think it's doing. And by not having to check that all the inputs and objects for each clone are identical to the prototype, saves you an enormous amount of effort again. And if you're building a large model, this is a very important consideration. So this is just a little preview of what some models can do. When you're building complicated models and you need to reuse, you have the same sort of things. A workstation is the same. You have 5 or 10 workstations that are all identical. Submodels can save you a lot of time and grief. So it's something that model builders should be aware of. Then let's move on to functional programming now. This is something that's more mathematical and probably a little bit more abstract for most people. We're used to dealing with values in JaamSim, and so a value is anything that appears in an expression. It could be values can be numbers, objects, arrays, or hash maps. So you can create attributes that hold an array or a hash map, and you can use all these things in expressions. With functional programming, a new type of value is introduced called the Lambda function, and this is a function that can be treated like a variable, like a value. So a Lambda function can be assigned to an attribute. It can be returned by a custom output. It can be returned by a regular output from JaamSim. And once you have the concept of a function that is a value that can be a function, now you can have functions of those types of values. So higher order function is a function that takes one or more Lambda functions as an input. And this is something, if you Google functional programming, you'll see all this stuff in a Wikipedia article or in various descriptions for programming languages. So there's nothing new here. What functional programming does is allows you to do things that you normally have to do with procedural code, with loops in a programming language. And in the expression system doesn't really lend itself to or any expression system doesn't really lend itself to procedural code. Expressions are normally work with functions that are declarative. So this is a way of doing complicated things in the expression system without the use of like loops, without the use of procedural code. So let's look to see how that works. So first of all, we have to be able to define a Lambda function. And you can see the syntax here. You define one or more variables for the function. In this case, the example here, x and y. And then you follow that with a formula enclosed in brackets. So in this case, x and y are being added, and the result of the Lambda function is the sum of the x and y. And to evaluate a Lambda function, you just provide it with an argument list enclosed in brackets. So here in the example, the argument is one. The arguments are 1 and 2, and the Lambda function returns the sum of that, which is 3. In the little input builder screen here, I've done it a little bit differently. I've defined a local variable add to be the Lambda function. So remember, the Lambda functions can be assigned to variables. And then I execute the Lambda function by providing with the arguments 1 and 2. And you can see the result at the bottom. The present value of this expression is 3. So it's actually quite simple, and this is a way you can use the input builder to test simple expressions as long as the input return is consistent with the input in the question. In this case, I'm using an expression entity which returns a number. So if you want to return an array, you can't use that, unfortunately, and I'll show you how to get around that shortly. So the higher order functions are typically used to process an array of values, and that's how they're used in JaamSim. So the array could be just a list of numbers, or they could be a list of objects, or array of other arrays, or even array of Lambda functions. And there are four different higher order functions that are defined in JaamSim: map, filter, sort, and reduce. Map, filter, and sort return arrays, and reduce returns a single value. So let's see how these functions work. So the map function is pretty much the simplest one. It applies a Lambda function to each element of the array. So in the example here, the Lambda function is 2 times x, where x is a single argument Lambda function, and it's being applied to the array containing the numbers 3 and 2, and it's returning another array containing the values that were created by applying the Lambda function. So in this case, 3 multiplied by 2 is 6, 2 multiplied by 2 is 4, so the returning array is 6 and 4. And the line below that here shows just another way of doing it, defining a local variable func, which is assigned to the Lambda function, assigns a local variable array to the array 3, 2, and then it returns the map function applied to the function and the array. So using Lambda functions for numerical values is great for showing examples of how things work, but it's not very useful. And anytime you use a Lambda function in JaamSim, you'll probably be applying it to an array of objects. So for example, if you had an array containing a list of queues, and you wanted to obtain an array containing the lengths of those queues, then you would use the example I've given here, where the Lambda function is returning the queue length output for each queue. So note that the Lambda function doesn't know what kind of object it's expecting, but if it does not have a queue length output, it'll return an error. So it's not strongly. JaamSim expressions are not strongly typed. So it's nice to be able to test complicated expressions, and because Lambda functions return arrays instead of a single value, you can't just use an expression entity like we did before. The easiest way to test them is to create a custom output using the custom output list input. So in this example here, I've created a custom output named value, and I've then provided assigned it to the or provided the expression which is looked at as being the expression involving a higher order function to be tested, and you can see that the result of that expression. You have to see the result of that expression. You have to look at the output viewer, and under user-defined outputs, you'll see value and then the 6, 4 output from that expression. So you can test any kind of complicated expression this way. It doesn't have to return a number. It can return a value. It can return an array. It can return an entity or an array of entities, or a hash map or anything, and you'll see it displayed in the output viewer. So the the next one I wanted to talk about is the filter higher order function. This is another very simple function. In this case, it's returning a subset of an array, of the elements in an array that satisfy the conditions specified by the lambda function. So in the example here, the lambda function is the element must be greater than 2. So if you apply that to the array containing 3, 2, and 6, only 3 and 6 are returned because those are the only ones that are greater than 2. So a more that illustrates the function of it. A more common application in a JaamSim program would be, say, wanting to know which queues are non-empty, and there the example here shows testing the queue length greater than 0, applying it to three different queues, and it returns the non-empty ones. So the last higher order function I want to talk about is the reduce function. And it's more complicated in the other ones, but it's probably the most useful. You saw that John Beasley used this in his baggage handling model. The reduce higher order function uses a 2-input lambda function, and it applies the first argument to the elements in an array. The second argument is the one that's labeled a cum, and then the names of the local variables are arbitrary. It is a value that's maintained between each step of the calculation, and the reduce function also has an input for the initial value of the cum variable. So probably the best way to understand all this is to look at some examples. So the first example shows the function of x plus a cum. The initial value for a cum is 0, and it's being applied to the array containing 1, 2, 3. So what it does is the first step, it takes 0, the initial value for a cum, and adds it to the first element in the array, which is 1. So cum is now 1. And the next pass through it, a cum is 1, and you're adding the second element in the array, which is 2. So the total now is a cum is now 3. And the last step is a cum is 3. You're adding 3 to it, and you end up with 6. So basically, this reduce function with this lambda function is just providing the sum of that array. And you can do similar things with and the second example shows looking for the maximum of the elements in the array, or applying the OR function operator to the elements of the array. So to understand maybe more clearly what the reduce function does, there's some pseudocode here that shows how it works. So the first line of the code is assigning the initial value to the cum variable, and then summing over the elements of the array and applying the lambda function to it, assigning that to a cum, and then finally, when it's done, to return the cum value. So as I said, this is a very useful function, and it allows you to execute quite typical loops without any procedural code. The last thing I want to talk about now is the watch list input. If you'll excuse me just for a second. Sorry, I've got a cat in here who's been harassing me. So the watch list input. So the watch list input is an input to the expression threshold object. Expression thresholds are great. They are very useful for implementing model logic. The only trouble is that they're really slow, and they're slow because the expression is evaluated at every event time. This is called a conditional event in discrete event modeling. So here's an example of the use of an expression threshold. The entity generator is generating entities until as long as the number of entities in the queue plus the any entities on the way to the queue is less than 4. So as soon as you have 4 entities in the queue or on the way to the queue, the entity generator stops. And then it resumes again when the queue starts to be emptied out. So as I said, this is a very trivial example of the use of expression threshold. Now, you can find out how much of computing time is being used by the components of a model using the event viewer. And one of the options in the event viewer is the execution time profile. And if you let the model run for a while and then clear the results of the profile and start collecting results, you'll see very quickly the percent of total time values for the various operations in the model give you an idea of how much time is being spent. So in this case, if you look down to the second line in the event viewer there, the expression threshold is using 22% of the processing time. And as I said, this is a very simple model. In a complex model where there are lots of expression thresholds, it's not uncommon to see the expression thresholds using up 50% or more of the computing time, at which point you really need to do something about it. The model is just being dragged to a halt by the expression thresholds. The solution is to use the watch list function. And what the watch list does is specify the objects in the model that have the ability to change the expression. In this case, the expression refers to Q1 and entity delay 1. And so it's pretty obvious that if the watch list should be entity delay 1 and Q1. Whenever those objects change state, you need to reevaluate the expression threshold. If they don't change state, then the value is not going to change. So there's no need to reevaluate the expression. If you're ever often with a complicated expression, you're wondering whether you've really identified all the things that all the objects that should be in the watch list. In which case, you set the verify watch list input to true, and then the model monitors both the watch list and it executes the condition at every event time. And if it changes state without the watch list, when the watch list doesn't activate it, then you'll get an error message. So with that change, with adding those two entities to the watch list, now the execution speed for this simple little model increases by about 50% from 320,000 speed up factor to 450,000 speed up factor. So in a simple model like this is so fast it doesn't really matter. But in a complicated model, can be the difference between a model taking 2 hours to run and 1 hour to run. So it can be very worthwhile. So that's all I wanted to talk about today for advanced features. These are the ones I'm talking about are things that really anybody who's building a complex model needs to be familiar with. The two things that what we haven't talked about that advanced modelers should be familiar with is the syntax for the configuration file, so that they can edit the configuration file manually. JaamSim has the ability to allow that, as well as still using drag and drop and uh, drag and drop and graphical editing. So you can combine both those methods at the same time, depending which one is most convenient at that point. And then you can use Git to do for version control, so you can keep track of all the changes that are being made to your model. And if you're building a big model, or even not so big model, and executing a project, I would really recommend using version control to keep track of all the things you're doing. Otherwise, it's very easy for mistakes to creep in, or for you to forget what version of the software, what version of the model you're using at any given point. So that's everything I wanted to talk about today, and thank you very much.
Thank you, Harry. Are there any questions?
I've got a question for Harry. If I don't, I'll just ask it. So Harry, when you're going between using the GUI versus manually editing the config file, is it still that you sort of have to have a separate sort of notepad program to do that, or is there a way to work directly with the config file within the JaamSim interface?
No, you do it externally to JaamSim
Okay.
using Notepad++, just the way we did it at Asenco.
Okay.
Yeah, in fact, that whole methodology was what we did we developed at Asenco, because we were building these enormous models, and we wanted to be able to rearrange the graphics, but interactively through the UI, but without messing up all the code we had edited very carefully manually, complete with comments, and nicely formatted and everything. So we came up with a good way to do that, and that really was essential to keep our models tractable when they became very large, and they needed and also make them easy to relatively easy to audit.
Yeah, and I'll attest to that. That combined workflow is very efficient. There's a question from Anthony. Do you want me to read it, or do you want to read it out loud?
Read it.
Okay. Could you Oh, what's happening? Okay. Could you comment on submodels, i.e., anything to be careful about? Also, is there a practical way to maintain a submodel prototype in a separate file from the file in which you're using?
Yeah. So submodels that can get tricky, but we've been through a couple of rounds of debugging with some people on the forum. I forget whether it was Anthony who I was working with on that, but there were a couple of people or at least one person who posted a model that had a JaamSim tied in a knot and had to be work to get submodels working more reliably. But I think the submodels should be just fine now. I don't think you have to be too cautious about them. Putting a submodel into a prototype into a separate file, you can certainly save the submodel prototype and a separate file so it can be reused, and you could also set it up so that model is imported rather than included in your configuration file. But it still has to be imported, and it will still appear in your model. So the prototypes should be sort of put over in a corner of your model someplace out of sight, where you can get to them if you need to, but generally aren't cluttering things up.
Great. There was a comment from I don't know if I'm pronouncing your name right, but Kanat. Um, so he troubleshot something similar by deleting the clones of the submodel.
Yeah, so this is this was a real head scratcher for us because I remember that post, corresponding with you. Um, the both Harvey and I weren't able to reproduce the slow execution speed, so weren't sure what was going on. Um, I mean, I'm happy to work with you some more on that if and find out what exactly it is about your situation that was causing it to execute so slowly. I see you're on, Knut.
Yeah, my comment here was just for info. So there was some weird experience there, and you were not able to recreate it. I was able to recreate it on other PCs. Also we thought it was something to do with the Java version, which it turned out not to be. So by coincidence, I deleted the 5 clones I had made and put just one, recreated one of the clones, and then it worked like there was no problem at all. So it was really strange. And yeah, so just a tip, deleting, if you have some performance issues, trying to delete some clones and recreate them at least worked for me on this issue here. But it could be, the model is a bit old. It's I've been building it for 4 years now. The submodel feature I included, I don't know, a year or two ago. So it might be something with the versions, I don't know, but now the problem is solved, so I'm happy now.
That's interesting. So, and you were able to reproduce it on a non-work computer.
Yep.
Yeah. So it wasn't. We're wondering whether it was a virus, antivirus software, or some aspect being locked down by your IT department. So even on a personal computer, you were able to reproduce it.
Yep.
Okay, well, but when we both Harvey and I looked at that, we actually had your configuration file and we loaded it and ran it, and it ran just fine on our computers.
Yeah.
Now it's possible that you were able to do something that triggered it just from the way you work with it. Sometimes just detailed differences can make a difference.
Yeah, I didn't realize what you told earlier here tonight, that the clones are not saved. They are recreated every time. So which contradicts kind of the trick I used to fix it. So I thought the clones were saved in the. Explain that.
Well, the submodel clones are saved. It's the because they have to be but the components of the clones, the objects making up the submodel, those are recreated. Those aren't saved. They're recreated at load time. Okay. Have you looked at your input file and understand how it works?
Yes. Yeah, I have, and I needed to because there were some other things with duplication of labels and labels being misplaced, also related to
I remember that.
But I understand that there's another subject. So to clean that up, I also went through the CFG file to try to do it that way.
Yeah.
To manually delete some text there.
Yeah, so when strange things are happening and it's something that we're trying to debug, then understanding the configuration file is really helpful. Because it's okay. Well,
otherwise, I just support the Lambda functions you explained. They're really useful, so that the syntax is a bit tricky to understand, but through the examples in your manual and in the forum, it's possible to learn. And then once you handle it, it's a real gift. So that's really useful.
Good.
Thank you.
Okay, good. Thank you.